Hello civil engineers, welcome back to the lecture. So in this lecture we'll see how the material calculation is to be taken care of. So if you remember, so far we have done the complete estimation, right? So all this were the estimation what we have done. We have finally taken out all the quantities that is required. For example, if I go back to my foundation part, right? So here we have found out that in this particular foundation I require 33 cubic meter of the concrete. In the same way, if I come back to the other part, like up to the plinth level, so in the beam I require this much amount of concrete, right? So this is my beam. Total beam concrete quantity is 10.67 cubic meter. So finally we have done all the quantity, but we don't know for this particular 10.67 how much amount of cement, sand and aggregate is required, because everywhere we have told that we are making use of M20 grade of concrete, right? But we haven't found what is the cement, sand and aggregate required. So those calculations will take out from here onwards. So it will come under the costing part. Okay, great. So I'll start with this now. So let us consider I have a M15 grade of a concrete of 1 cubic meter. I want to find for this 1 cubic meter of a concrete to be prepared of M15 grade, how much amount of cement, sand, aggregate and water is required. Okay. So always remember, to find the cement quantity, what we do? Yeah. So see, we'll start like this. Okay. Yeah. We'll start like this. So the formula will be, I want to find for 1 cubic meter, right? I'll write 1 here. I'll write 1. For 1 cubic meter, I'll find. So I'll multiply this by 1.54. Now don't ask me why it is 1.54. I'll explain you. First we'll finish the calculation. So multiply this by 1.54. For 1 cubic meter, we'll multiply this by 1.54. So 1.54 is a constant. And again, I'll multiply this by 1, because cement, if you remember M15 grade, what is the ratio of M15? The ratio of M15, I'll write it here. It is 1 is to 2 is to 4, right? So this is M15 grade ratio. This is a M15 grade ratio what we have, which is 1 is to 2 is to 4. Out of that, 1 is cement, 2 is sand, 4 is aggregate, right? So in the same way, I've done it here. So into 1, 1 is for cement. This I'll divide by the total ratio. Total ratio is 1 plus 2 plus 4. How much it will be? 4 plus 2 is 6. 6 plus 1 is 7. So 7. Okay. So whatever answer I'll get, try to do this manually. So 1 into 1.54. 1 into 1.54 into 1 divided by 7. So this is 0.22. So this is 0.22 cubic meter, CUM. This is cubic meter. Okay. Always remember, whenever you order the cement you are going to order in bag. If you go to the market and tell, I want 0.22 cubic meter of the cement, then no one will understand, right? So if you go to the market, you should tell in number of bag. So whatever cubic meter I have, if I want to convert this into bag, what we usually do, we can divide this by volume of one bag of cement. Listen, volume of one bag of cement. See, one bag of cement will be 50 kg. One bag of cement will be 50 kg. Okay. What will be the volume of this? The volume is 0.035. So this is the volume of one bag of cement. So this is a total cubic meter, whatever. This is a total volume. So if I divide by volume of one bag, will I not get the number of bag that is required? Obviously, I'm going to get. So just divide it by 0.035. I'll do it. 0.22. You divide it by 0.035. So I'll get 6.28. Okay. So I'll divide it by 0.035. Okay, it can be sometime it is 0.0347 also. Few people take that also. You can take 0.035 also. If you do that, how much you'll get? I'm getting 6.29. So 6.29 bags of cement is required. Got it? I got 6.38 here. I'll tell you how it is coming. I'll tell you why I've taken 29 here. But this is understood. Okay. So now I'll delete everything and let me come back to this. Now, how did I get this 29? I'll explain you. See, so we know that density is equal to mass by volume. We know that density is equal to mass by volume. Okay, mass by volume. So if I want to find the volume, what I'll do, if I want to find the volume, it will be mass by density. So it will be 50 by Okay, if I want to find the volume, it will be how much? It will be mass by density, isn't it? Fine. So volume will be, what is mass? Mass means one bag of cement, it is 50 kg. I'll divide by density of the cement bag. So the density of the cement bag is 1440. Okay, so I'll write it here. One bag. One bag is 50 kg of the cement. And if you ask me what is the density of the cement bag. Okay, density of not cement bag. I can say density of cement. Density of cement is 1440. It is kg per cubic meter. Okay, kg per cubic meter. This image is understood? Great. So try to do this calculation, you'll get the same answer what I told earlier now. If you do this calculation, 50 divided by 1440, it will be 0.0347. That is why what I did, I divided this answer directly by 0.0347. This is one method of doing. Second is that we can also multiply this by 29. How do you get this 29? It's very simple. If you divide, if you do 1440 divide by 50, if you do, try to do this, you'll get 28.8, which you can consider to be 29 back 29. Okay, so you have two options. Either you multiply the answer by 29, or you can divide the answer by 0.0347. Or even it means that if you do 1 divided by 0.0, if you do this way, 1 divided by 0.0347, in that case also you'll get the same answer, that is 1 divided by 0.0347. So here also you'll get 28.8, which I'll consider to be 29. Okay, you're getting my point. So it's some people, what they do, they whatever answer they get, they multiply it by 29. Few people, whatever answer they get, they divide it by 0.0347. But at the end of the day, you're going to get the same answer. There might be slight change. Instead of 6.38, you may get 6.28 like we got in the previous case. But that is the right way to do. Got it, no? So everything I've explained you. So this was about the cement calculation. So finally, if I want to prepare a M15 grade of concrete of 1 cubic meter, I require 6.38 bags of cement. Now come to the sand. Again, sand also it is the same thing. 1.54 will remain constant like we have it here. I'll multiply this by 1. Why it is 1? Because for 1 cubic meter I am doing. Now I'll multiply by 2. 2 is the this thing. What is that? We already written it here, no? The ratio of M15. M15 it is 1 is to 2 is to 4. Right? So here the 2 is sand. So that is why I have taken the sand proportion. Sand proportion is 2. So I'm multiplying by 2. Divided by the total ratio. The total ratio is 1 plus 2 plus 4. And now you do this. Okay. So let me do this manually. 1.54 into 1 into 2. Divided by 1 plus 2 plus 4 you are supposed to do. Try to do it manually. 1.54 into 1 into 2 divided by 7. So I'm getting 0.44. Okay. So I'm getting 0.44. So again, this 0.44, this is in cubic meter. This is in cubic meter. But always remember, whenever we order the sand, isn't it? We never order the sand in cubic meter. We order the sand in cubic feet. This is CFT, that is cubic feet. So this 35.31 is a conversion. So if you want to convert, or let us say 1 cubic meter is equal to 35.31 CFT. If somebody asks you, tell me how much is 1 cubic meter in the CFT. So this is a conversion which you should know, which is 35.31 CFT. Okay. Again, how did this come? It's very simple. What is 1 cubic meter? 1 cubic meter means 1 into 1. So this is equal to 1 cubic meter, isn't it? And we know that 1 meter, we also know that 1 meter is equal to 3.28 feet. Do you agree with me? 1 meter is 3.28 feet. So this is 1 meter by 1 meter by 1 meter. If I convert this again in CFT, in feet, so it will be 3.28 into 3.28 into 3.28. If you try to do this, now you'll get 35.31. So that is why I can say 1 cubic meter is equal to 35.31 CFT. Okay. That is why what I have done, I multiplied this by 35.31. So if you multiply 0.44 into 35.31, you will get 15.53 CFT. Got it? Now come to the coarse aggregate. Okay. So again, for the coarse aggregate, again it remains the same. This will be 1.54. Multiply this by 1. Now this multiply by 4 because the aggregate ratio is 4 here. So I've taken 4. Then you divide by the total ratio. The total ratio is 1 plus 2 plus 4. And now again you multiply this by 35.31 because sand and aggregate both are ordered in CFT. So try to do this calculation. You'll get the answer as 31.07 CFT. Got it? Up to here your concepts are clear. Now if I give you any problem, you can do it on your own. Okay, good. Now last thing is about the water. Water also we need to find. No, so to find the water, always remember we need to know about the water cement ratio. What is this water cement ratio? Whenever you prepare a concrete, we have certain limits, right? That water cement ratio should be so and so. So especially when you go for the design mix and all, mix design and all, they mention like this is a water cement ratio that we are supposed to use. So let me show you that. Yeah. So right now I'm using IS 456 2000 code book. And if you come to the page number 20, you can see here for different exposure like mild, moderate, severe, very severe, and extreme. In RCC, they have given what is the maximum water cement ratio that you're supposed to use. If you're using a concrete in a mild, maximum you can go up to 0.55. And minimum, that is for extreme condition, maximum is 0.40. So usually this water cement ratio lies in between 0.4 to 0.55 to 0.55. But again, it totally depends on the mix design that you're preparing. So now you can assume, for example, I'm doing for, let us say, M20 grade of concrete, or let us say M15. We don't have M15 here. We'll go with M20. For M20, he's telling maximum it has to be 0.55. You cannot go beyond that. So I'll say I'll use 0.5, or let us say I'll use 0.45. So this is my water cement ratio. Okay. But if you want to learn how this water cement ratio is and all done, then there's a course of mine on by name concrete technology. There I've explained you all those things. But here it is not required for you because we are more concerned in the estimation part. We don't want how these things are coming, how these things are mixed, designed and all. But if you want to learn, you can enroll in my concrete technology course where I've explained you how all these things are arranged. Now you understood, right? From where I'm taking all these things. Good. So I'll go back to this now. So that is why I've taken my water cement ratio will be 0.45. So water I want to find, divide by cement I need to do, right? See, this is how it is. So water divide by cement will be, let us consider it to be 0.45. Okay. Water I don't know. Cement I know, right? So for water, if I want to find the water quantity, it will be how much? 0.45 multiplied by cement. Okay. But here what has happened? Cement is in bag, but we know that one bag is 50 kg, isn't it? So what I'll do, I'll multiply this by 0.45. Okay. I'll multiply this by cement quantity. The cement quantity I don't know, but bag is there. That is 6.38. 6.38. And also know that one bag is 50 kg because I have 6.38 bags. I want to convert in weight, no? Okay. So I'll multiply this by 50. So when I do this, whatever answer I get, no, I'll get that in liters because water is a volume, right? Water should be in volume. So it will come in liters. This much is understood? Great. The same thing I've explained to you here. Therefore, water in liters will be cement bag multiply by water cement ratio, which is 0.45 multiply by 50 because the weight of one bag is 50. So 6.5. Why it is 6.5? Okay, wait. Okay, fine, fine. 6.5 why I have taken is because 6.38 I can consider to be 6.5. Else I can write 6.38 also. It's okay, not an issue. Okay. Instead of writing 6.38, I have taken a round figure and made it as 6.5. Okay. So 6.5 multiply by 0.45 multiply by 50 you do. You get 147 liters of water is required. This much is understood. So this is how the material calculation has to be done. So try to practice up to here. Try to understand. I'll give you one more assignment. Okay. Instead of I have explained you for M15, no, you do one thing, you do it for M20. You do it for M20 and you know the ratio it is 1 is to 1.5 is to 3. Okay. Try to do it for 1 cubic meter. And also whenever you go for the interview, right, you should remember these things. If you're applying for the site engineer job, or even if you're applying for a quantity estimator job, at any cost, if somebody asks you, I want to prepare a M15 grade of concrete, tell me if I want to make 1 cubic meter, how much cement sand aggregate is required. So then you cannot tell, give me a pen and paper, I'll do. No, this you have to remember. So always remember, if I want to prepare a M15 grade of concrete for 1 cubic meter, so I require almost 6.5. You can remember 7 bags. Remember 7 bags is required of cement, and almost 16 CFT of a this thing is required. What is that? Sand is required, and you require 31 CFT of a coarse aggregate. and water roughly you require 150 liters, I'll consider. Now if somebody tells you like M15 is there, I have 50 cubic meter, based on it just multiply the answer. That's it. For 1 cubic meter you know the value. If it is for 50, you just multiply everything by 50, 50, 50, 50, you'll get the final answer. Got it, no? Great. So in the next lecture I'll teach you one more method, same method. There's one more method which I can adopt, and then I'll teach you how all these things has to be done on the Excel sheet. In the Excel sheet, we'll prepare one Excel sheet which will act as a template for us. And then if any drawing comes to us, or if somebody asks us how to find the cement sand aggregate quantity and all, we can just plug in the values there and you'll get the final answer, right? Yeah. So we'll see you back in the next lecture. Thank you.